Okay, guys, so what we're looking at today is still learning unit 6, chi squared. We can call it part 2, and that is what we call user-defined distributions, or otherwise known as goodness of fit test. So it's the goodness of fit test. In the textbook, that's what it's referred to, but you can refer to it as user-defined distributions or goodness of fit. Now, basically, what it is it is the exact same 5 steps. However, there is a few minor differences. Now, the first one is that we no longer work with a table that is two-dimensional. So, for the normal chi-square, we know that we've got a table that is what I call two-dimensional. We've got female, male, beat, grow, and youth, and it looks like that. So we've got two categorical variables. Okay, so the one categorical variable is gender and the other one is magazine preference. Now, for goodness of fit chi square, the table looks a bit different, and that is usually how you identify it. What you will be given is something like transport mode. So we've got transport mode, and what you observe would look something like this. Bus. So you've got a transport mode, train, car, taxi, bus, and you will have a percentage or a value. Okay, so the data will be presented in a different structure. For your normal chi-square, you will have a two-dimensional table where you're working with two categorical variables. For your goodness of fit chi-square, you will only have one categorical variable and different categories or classes as they refer to it. Now, if you remember what we went through in our previous learning unit, you should pick up that what is the big difference. Now, the big difference is your degrees of freedom. Here was R minus 1, C minus 1, number of rows, number of columns. But now, if we look at this, we've only got one column. So that would be 1. 1 minus 1 is 0, which means the degrees of freedom would be 0, which is untrue. So for your goodness of fit, you calculate your degrees of freedom in this manner, where K is your number of classes. And what is a class? This is typically a class. So here it would be 1, 2, 3, 4 classes. Okay. And M is a estimate on parameters, which you need to look at table 10.10. And if we look at that table, we will see that for the probability distributions that we work with, there is two kinds for this syllabus that we are interested in. The first is for a normal distribution where we are looking at the population mean or standard deviation to be estimated. And the second one is the user defined. So it's either 0 or 2. We will not be looking at a binomial, Poisson, or uniform goodness of fit test. We will only be looking at normal and user defined as stated. So M is, if we were looking for the mean, M is 2. If it is user defined, M is 0. And it will almost always be user defined, which will mean M is 0, so it's just K, your number of classes, minus 1. Okay, so guys, that is the second part to this learning unit, and I'm going to do a quick example that is in the textbook to show you guys exactly how to calculate your user-defined scenario. All right, so let's do example 10.3, and if we read it, we say Metro Rail commuter service is studying the daily commuting patterns of workers into central business CBD of Cape Town. A study conducted 7 years ago found that 40% of commuters use train, 25 cars, 20 taxis, 15 buses. A recent survey of 400 randomly selected commuters found that 135 commuters use trains and. Now, the question is, can Metro Rail conclude that commuting patterns into the CBD of Cape Town have changed since the study 7 years ago? All right. So what we've got is we've got the transport mode of train, car, taxi, and bus. And out of that, they give us that it is train is 34%, 29%, 24%, and 14%. And this is our percentage for our observed values. So that was 7 years ago. Then what we do is we get a new value which is given to us. So let me just see which values I've got here. No. Okay. So these ones I need to take out. I followed the wrong structure. Okay. So reading from the question, let's start there. From the question, we've got conducted 40% is trains, 25% is cars, 20% taxis, and 15% bus. So what we've got is, this is our percentage expected. Now, why is this our percentage expected? Because we want, if we read the question, we want to see whether the new values have changed or not. So we want to see if the new values conform to what we expect to happen. So we've got new values and then we've got the old values. For us to test whether the new values have changed, we need to compare the new values to the old values. So we are expecting the new values to be similar to the old values. All right, so that's a percentage FE. Now what they've done is they have given us an actual number for our observed. So they said 135 used trains, 115 cars, 96 taxis, and the remainder traveled by bus. So we need to calculate what the remainder is out of 400. So we just said 400 minus 135 minus 115 minus 96. and that will give us 54 on bus. But guys, what we need to do is these values will always have to be in the same format. So we've got percentages here, and we've got actual values here. So what we want to do is we need to get them into the same format. And in order to do that, we need to convert these values into actual numbers, into a number FE. So we know that total is 400. So if we want to convert 40% into a number and not a percentage, the total still needs to add up to 400. So 40% of 400 would be 160. 25% of 400 would be 100. 20% of 400 would be 80, and 15% of 400 would be 60. Okay, now we've got the same values because we can't work with percentages and with numbers in the same column. And guys, then we use the same formula. Over here, we use the formula as in the textbook, FO minus FE squared over FE, and we add them up and we get our chi-square stat, and all the rest stays the same. So what is different here is our degrees of freedom will be k, number of classes is 4, minus 0 minus 1, because this is a user defined. They've given us the expected values, so m is 0, so our degrees of freedom would be 3, and our alpha was stated, and that is 5%. So thereby we can get our critical value and calculate the rest.